Hello guys of YouTube or gals or whatever. Today I'm going to be showing you why this guy is a complete fraud because he can predict your numbers like he says, but he can't possibly not predict your numbers the way he's set up to work. So I'm going to just run through this how it's meant to, you can read that. But basically he said pick a number, so 24, then add them together, 6, take away that from that, you get 18. Okay, look at this chart, it says 18, so that's my symbol, and he's magic. Just by magic, yep, magic, magic, magic. Oh my god, that's my number. Oh, my symbol even. Well, I'm just going to prove him how he works, basically. So, turn the music off again. Think of a number. This is how I'm going to disprove him. Not disprove him, prove he's a fraud. I'm going to pick four numbers at the same time. Any random numbers. Okay, these are the random numbers. Add them together, that's 8, 12, 5, 11. Take them away from each other. That gets you 9, that gets you 36, that gets you 18, that gets you 81. Alright, and see, pay close attention to these numbers, expertly squared across, or rectangle. So, this chart, and this is how you can know he's a fraud, or whatever, or a fraud. He's not charging you any money, but you can tell. Just look at those numbers and look where they are. They're all the same symbol. How peculiar. There's no chance that this is luck, because you can also note that they're all the numbers of the 9 times table. All of them. They're all the numbers of the 9 times table. The ones on here, not the ones on the screen, because they've added random ones to try and fool you, like 86, that's not part of the 9 times table, but 63 is. You can go through them and look at all these numbers I've got. They all correspond to that same symbol. It's just every time you run it, the symbols change, but all of these numbers will have the same symbol. 9, 18, 27, and that's how he does it. Basically, he just picks the same symbol and he puts it to all the numbers in the 9 times table, because you always get a number in the 9 times table. So that's how he does it. Okay, so the second part of this is proving why it's always a multiple of 9, which is what this whole thing bases on, really, because every single number, 2 digits under 100, obviously, when you do this process, you always get a multiple of 9. I'll be showing you why. So let's think of a number, 46. Okay, now this is going to be algebraic, so if you don't understand algebra, stop now, learn how to. You never look back. No, I'm joking. So 46, how can this be represented in algebra? So this, the second part, I'm going to be representing as B, and 4 can be represented as A. But put this in algebra, that doesn't make sense, does it? Of course not. This, A plus B, if 4 was A, and that would equal 10, and that doesn't equal 46. But in deanery, or whatever, every time you go to the right, or left even, you go times by 10, because this column represents 1s, this represents 10s. You learn this in primary school. So if we stick a 10 in front of that, that would equal 40, that would equal 6. There, 46. So the whole thing, so we do 46, add them together to get 10, then we take 10 away, don't we? That's the next part. So what's this take away 10? It's what can take away 10 be represented as? So we add the two numbers together, so that'd be A plus B, like that. And that is because when we're just adding the two digits together, we're not actually taking into account their tens or ones value, we're just taking them as ones. So that would be A plus B. So we're taking this to conjoin the two bits together, we'd do 10A plus B, take away the solution to A plus B. And if we expand that out and take it away, we'd get 9A like a tactical move up. Now 9a, take away 9a. Yeah, just 9a. So now look at this 9a. This can be represented as 9a. So basically, the numbers you put in is basically timesing the first number by 9. This proves. So any number times 9 is obviously going to be a multiple of 9, isn't it? That makes logical sense. And this is proof why it always equals 9. So if we take an example, 23, you won't be able to see that because I've moved the piece of paper up. 23. 23, 23, 23, 23. How many times can I say that? Take that away like that. A is going to be 20 minus plus 3, take away 5. And because this take away 5 is 2 and 3, like we said before, A plus B. And this bit is 10A plus B. So 10A is 20, 10 times 2 is 20, B is 3 plus 3 minus 5. And if we work that out, that's 23 minus 5, that's 18. And 2 times 9 is 18. And that's proof. Thanks for watching. Goodbye.
Wow!